Hey Technopals, and welcome to Lesson 3, Part 3 of Electric Systems and Control of Simple Electric Systems, where we discuss electromagnets. Now we're going to look at a very interesting phenomenon, which is the relationship between electricity and magnetism. Electromagnets are magnets which are created using electricity. They are not permanent magnets. They are only magnets when electricity flows through conducting wire that is coiled around them. When the electricity is switched off, they lose their magnetism. Electromagnets are very useful for separating scrap material. Scrap material in waste dumps are usually a mixture of metals and non-metals. The ferrous metals, which are those that contain iron, are still valuable. It takes a lot of time to sort waste material by hand. As you learned in the previous lesson, ferrous metals are attracted to magnets. An electromagnet is passed through the waste material and all of the ferrous metals stick to it. The electromagnet is then moved over a collection bin. When the electromagnet is switched off, the ferrous metals are no longer attracted to it and they fall into the bin. Apart from being useful to sort scrap material, electromagnets are often used as components in other electrical devices. Some examples include in motors, to rotate the motor. In loudspeakers, an electromagnet responds to the sound signal and amplifies them. In computer hard drives, the electromagnetism is used to write and store data. In electric bells, electromagnet attracts and releases the hammer of the bell. And in a magnetic door switch, electromagnets can close and open doors. In all of these applications, the fact that the magnetic force can be controlled by switching the electric circuits on and off is the property that makes electromagnets so useful. For the next activity of making a simple electromagnet, you will need the following objects. A long iron nail, about 15 centimeters long. If you don't have a long nail, you can make a bundle of several pieces of iron wire. 3 meters of insulated copper wire, a size D cell or two size AA cells connected in parallel, a wire stripper, and metal paper clips. Point 1. Use the wire stripper to strip a small piece of the insulation from both the ends of the insulated copper wire. Wrap the insulated copper wire around the iron nail. Make sure that you keep the wire turning in the same direction. Keep the coils close together. Figure 7 shows an example of how to do it. Point 3. Now connect one of the stripped ends of the wire to the positive terminal of the cell. Point 4. Connect the other stripped end to the negative terminal of your cell. Point 5. Test if your electromagnet is working. See whether it can pick up paper clips. If the paper clips are attached to the iron rod, then your electromagnet is working. Point 6. Once you have tested your electromagnet, disconnect the wire from one terminal of the cell. Now try to pick up the paper clips. Are the paper clips attracted to the iron rod? And point 7. How can you see and use the electromagnets to pick up paper clips from one place and then put them in a different place? Now let's discuss a bit about how electromagnets work. There is a strong relationship between electricity and magnetism. The electricity in the wire coils created a magnetic field. The iron nails is right in the middle of this magnetic field. Because the iron nail is a magnetic material, it becomes magnetized by the field. The magnetic field from the electric current is made much larger or amplified by the magnetic field in the iron nail. Without the iron core, the magnetic field would be very weak, and when the electric current is switched off, the iron nail loses its magnetism. A safe note, the iron nail can become quite hot, so be careful not to burn yourself when carrying out the practical.